Discovering new functional materials is paramount to developing the disruptive technologies that we're going to need for energy conversion, energy storage, and energy utilization. Our overall objective of our Energy Frontier Research Center on next generation of materials by design is to discover novel functional materials, including non-equilibrium systems, in a predictive manner. One of the goals is to really go beyond the Edisonian approach to materials discovery and accelerate the discovery of materials by integrating high-throughput synthesis and characterization with very detailed theoretical studies.
Materials design does not exist just by the computations feeding the experimentalists. The experimentalists have to give the information back to theory, and we work very much in that loop when we do materials design.
What's really interesting, what this team now is trying to do is try to go beyond materials that are easy to make, materials that are what we call thermodynamic ground state, because those we know how to make. Can we understand like which metastable compounds can be made? So that way we know what space we should design over, and this has never been done before.
The Polymorphs project relates to trying to develop ways to select out or control what polymorph or what different phase of a material you make. In order to understand how that works and then ultimately control it, you have to understand that whole process. That process then involves doing real-time characterization so we can actually watch the evolution of the phases and the different materials as they're being made.
What we've done here is develop tools to watch the formation of materials in situ.
Adding kinetics adds the synthesizability component and understanding how reactions occur and what mechanisms you might use to actually get to one of these materials.
We're looking at things like atomic layer deposition, pulsed laser deposition, hydrothermal synthesis, solution chemistries, sputtering. And so each of these different techniques provides something different or allows us to change a different range of parameters so that we can see how we can access a lot of these high energy polymorphic structures.
And by understanding how things start and through the whole process and not just the two endpoints, we can better understand that reaction and make more informed decisions about the materials that we're trying to target.
Over the past few years, there's been a great discovery in materials for photovoltaics where lead iodide-based perovskite materials have shown great promise for use in high-efficiency photovoltaics. As a project in the Center for Next Generation Materials by Design, we're trying to learn the basic solid-state physics lessons from these materials' high performance and search across large existing databases of materials to find promising new candidates which could have these same high-efficiency performance and potentially get rid of the lead and also perhaps be more stable.
This search is actually enabled by the existing data calculated by the Materials Project, which are our partner.
There's very much a synergistic effort between the NREL EFRC and the Materials Project. The EFRC is feeding not only more advanced methodologies of computing materials, but also just the raw data, because they're expert at some of the materials properties that we're looking for, and they're now computing lots of them, and we're feeding that directly into the Materials Project, and we'll make that available to the rest of the public. I think this is the future.
One of our key missions in our Energy Frontier Research Center is to actually develop the next generation workforce for materials science and materials discovery.
I find that working in a collaborative team allows me to interact with more people than I normally would.
I've gotten a chance to see things that I wouldn't otherwise ever see.
EFRC has enabled us to put together a team, and we've been really lucky to put together a set of unique talents, and it's only through that kind of assembling the right kind of group that we can actually address these kinds of big problems.